So on the test, you'll have the same stuff from the quiz. Make sure you guys know how to do the product rule, the quotient rule. Make sure you know how to find a tangent line, the velocity, and then the newer stuff, make sure you know how to do the chain rule and the implicit differentiation. So let's take a look at the first question. Find the tangent line to the graph of the function at the given point. How would we find the tangent line? What do? We find the derivative to find the slope. So our derivative would be negative 2x. What would we do next to find the slope? Awesome, we're going to plug in the x. So I'm going to plug in 1 into the x, so it would be negative 2 times 1. So negative 2 would be our slope. So this question is asking us for the tangent line, so we need to come up with the whole line. So y minus y1 is equal to m times x minus x1. So our point here is going to be our x1, y1, and our slope. So y minus 6 is equal to negative 2 times x minus 1. Put it into slope-intercept form. So distribute the negative 2, negative 2x plus 2, and then add 6. This would be negative 2x plus 8. So that would be our tangent line. All right, let's look at the second question. A ball is thrown straight down from the top of a 417-foot building with an initial velocity of negative 26 feet per second. Use the position function below for free-falling objects. So we have negative 16t squared plus our initial velocity here gives it to us. So we're going to plug that in. So this is actually minus 26t plus our initial position, which is 417. So this is our position function. How do I find the velocity? What do I need to do? Do what? Take the derivative. We're going to take the first derivative. So when we take the derivative, we have negative 32t minus 26. So to find the velocity after 4 seconds, we're going to find v of 4 and plug 4 into our t's. So negative 32 times 4 minus 26. So negative 154. Negative 154 what? Feet per second. Awesome. For the third question, how would we find the derivative? What would we need to do? Quotient rule. What about for the next one? Product rule. What would we need to do for the next one? Chain rule. Let's practice the chain rule. So our derivative, take the derivative of the whole thing, or the outside. So this would be 20. The inside part stays the same when you take the derivative of the outside. So 7 minus x squared to the 4th power now. Then we multiply that times the derivative of the inside. What's the derivative of the inside? Awesome, negative 2x. We can simplify it a little bit. So this would be negative 40x times 7 minus x squared to the 4th power. Just as a review, here is our velocity. So it goes position, so it'll give you like your s of t. The derivative of that is your velocity. The derivative of that is your acceleration. What would we do for the next one? Can we just go ahead and do the chain rule? What makes this different? there's an x being multiplied, so what would we have to do? The product rule. So the first times the derivative of the second plus the second times the derivative of the first. So our first would be x. Our derivative of the second would be the chain rule. So 4 times the inside stays the same, 3x minus 12 to the third power now, times the derivative of the inside. What's the derivative of the inside parentheses? 3. Plus the second now, which is 3x minus 12 to the fourth power, times the derivative of the first. What's the derivative of x? 1. We can simplify this a little bit. 4 times 3 would be 12x times 3x minus 12 to the third power plus 3x minus 12 to the fourth power. Can we simplify it anymore? Do we have a GCF? What's our GCF? Not 3. 3x minus 12 to the third power. So I'm going to take that out. 3x minus 12 to the third power. We're left with 12x plus. When I take out a 3x minus 12 to the third power, I'm still left with 3x minus 12. So then when we combine our like terms in the last step, we have 3x minus 12 to the third power times 15x minus 12. So this would be our derivative. So make sure you notice the difference between this one and the last one that we did. There's an x in your first term, so we have to do the product rule. And then if this was a multiple choice question, it would probably be left in the most simplified form, which would be this one. All right, for the next one, same thing, doing the chain rule, or product rule and the chain rule. I'll come back if you guys want to see that one done, but let's look at the next one. What would we do first here? We're going to do the chain rule first, because the whole thing is in parentheses squared. So our chain rule would be 2 times 3x minus 1 over x squared plus 3 to the first power now. And then we have to multiply that times the derivative of the inside. What do we do to find the derivative of the inside? Quotient rule. So our quotient rule is low d high minus high d low over low squared. So low would be x squared plus 3 times the derivative of our numerator. What's the derivative of our numerator? 3 minus high, which is 3x minus 1, times the derivative of our denominator. What's the derivative of the denominator? 2x over x squared plus 3 squared. Let's simplify. I'm going to simplify the low d high that I just did. Let's distribute. So on top we get 3x squared plus 9. I'm going to distribute the negative too, so be careful with the signs here. This would be 6x squared minus 6x squared plus 2x. So when we continue to simplify our top, we would get negative 3x squared plus 2x plus 9. Then in our first part, I could distribute the 2 to the parentheses in there. So this would be 6x minus 2 over Here we have x squared plus 3 times x squared plus 3 squared. What would our denominator be? Awesome. X squared plus 3 to the third power. So this would be our derivative. This would be fine with me if you left your answer like this, but remember, if this was a multiple choice question, maybe the top's distributed out. So just check your answer choices. If you left it like this is perfectly fine. But another way that you could simplify is to FOIL out the top. The next question's asking us for the second derivative. So a couple different things that we could do here to find the second derivative. We can use our quotient rule, or this is supposed to be a comma, so it's really not supposed to be there. Or we could do x plus 16 to the power of negative 1 and move it to the top, and then we do our chain rule. So you could do it either way. What do you want to practice, the chain rule or the quotient rule here? Sure, let's do the chain rule. So if we had 2 times x plus 16 to the power of negative 1, this is the same thing. I just rewrote it to look different. From here we can take our derivative and use the chain rule. So I have negative 2 times x plus 16, because the inside parentheses stay exactly the same, to the power of negative 2 now, times the derivative of the inside. What's the derivative of the inside? Just 1. So this would just be negative 2 times x plus 16 to the power of negative 2. This is our first derivative. What would we do to find the second derivative? Do the chain rule again. So y prime prime, or our second derivative, would be 4x plus 16 to the power of negative 3. And what's the derivative of the inside? 1. So when you multiply it by 1, it just stays the same. To write this a little bit better, it would be 4 over x plus 16 to the power of 3. So these are the same thing. Either way would work. But remember, if it's multiple choice, it could be written one way or the other. So d2y over dx squared, this is the second derivative. All right, we'll do it. So the first times the derivative of the second plus the second times the derivative of the first. So our first would be 2x minus 3. When we take the derivative of the second, we have to do the chain rule. So it'd be 3 times x squared minus 5 to the second power. And then we have to take the derivative of the inside, which would be 2x plus the second, x squared minus 5 to the third power, times the derivative of the first, which would just be 2. So we can simplify. 3 times 2x would be 6x. Distribute. So 12x squared minus 18x times x squared minus 5 squared plus 2 times x squared minus 5 cubed. So this would be our derivative, but we could do a little bit more simplifying. Do you have a GCF? What? Awesome. X squared minus 5 to the second power. So when we take that out, we're left with 12x squared minus 18x plus 2. When I take out an x squared minus 5 to the second power, and I start with the third power, I'm still left with an x squared minus 5. So we can do a little bit more simplifying. I can distribute the 2. So we have 12x squared minus 18x plus 2x squared minus 10. And then combine our like terms. This would be 14x squared minus 18x minus 10 times x squared minus 5 squared. Can we simplify it any more? Awesome. In my second set of parentheses, I can take out a 2, so I have a GCF from that group. So 2 times x squared minus 5 squared. And then we have 7x squared minus 9x minus 5. So either one of these answers would work. These are both correct. But if it was a multiple choice question, you might see it either way. We wouldn't be able to distribute that into here anyways because it's squared. So if you have an exponent on your parentheses, you can't distribute it in. But we were able to distribute here in this step because there wasn't an exponent. But I wouldn't have been able to distribute into this one because it's squared. Let's say this was 3x plus 1 squared over x plus 4 to the 5th power. We'd have to use the quotient rule, and then when we do the quotient rule, then we'd have to do the chain rule. So these two are different because the parentheses are on the outside for the one on the right, and you'd have to just do the chain rule first. Once you get inside of the chain rule and you have to take the derivative of the inside, then you have to do the quotient rule. Next, we're going to find the derivative using implicit differentiation. So here, I cut off half the question, but I think, let's find the derivative first and then we'll worry about the point. So when we find the derivative, we'll just take the derivative of each term. So x to the 3rd power, what would our derivative be here? 3x to the 2nd, plus what's the derivative of y to the 3rd power? 3y to the 2nd power? dy dx. Awesome. Anytime we take the derivative of y, you have to put the dy dx. Is equal to, how would I take the derivative of 8xy? Product rule. Perfect. So our product rule, I'm going to call 8x my first term, and y is going to be my second term. So the first, I'll write it down for us. First times the derivative of the second plus the second times the derivative of the first. So our first is 8x times the derivative of the second. What's the derivative of y? 1 dy dx. So don't forget that dy dx. Plus the second, so y, times the derivative of the first. What's the derivative of 8x? 8. Then minus 5. What's the derivative of negative 5? 0. So here we want to find dy dx. So I need to put all of my dy dx's on one side, everything else to the other. So I'm going to subtract 3x squared, move it to the other side, and add 8x dy dx. Oops, subtract, sorry. Subtract 8x dy dx. So on the left side now we have 3y squared dy dx minus 8x dy dx is equal to 8y minus 3x squared. How do I get the dy dx as just one dy dx? What would we need to do? So on the left side, how would I combine these together? They're not like terms because one has a y, the other one has an x. What could we do? Do we have a GCF? Do we have a common factor? The dy dx is a common factor in both of them. So I'm going to take out the dy dx. And we're left with 3y squared minus 8x is equal to 8y minus 3x squared. Now, how would I get the dy dx all by itself? Awesome. I'm going to divide both sides by that 3y squared minus 8x. So our derivative, dy dx, is equal to 8y minus 3x squared over 3y squared minus 8x. The second part of this question either said evaluate at the given point or evaluate the slope at the given point. Either way, once we take the derivative, it probably says evaluate the slope. Once we take the derivative, what would we do at the point? Plug it in. I'm going to plug in 4 into the x and 3 into the y. So dy dx is equal to 8 times 3 minus 3 times 4 squared over 3 times 3 squared minus 8 times 4. So 8 times 3 would be 24. 4 squared is 16, and 16 times 3, 48. Over 3 squared is 9 times 3 would be 27. Minus 8 times 4 is 32. So on top, we get negative 24 over negative 5. So this would be 24 over 5. That's our slope. What if this question asks for the equation of the tangent line? Put it in point slope form. Take your point and your slope and plug it into point slope form. So it's the same thing we were doing when we found the equation of a tangent line in 4.2, just finding the derivatives a little bit more work now. All right, let's do the next one. We'll practice implicit differentiation again. So let's take our derivative. What's the derivative of 7x squared? 14x, perfect. What's the derivative of 3y squared? 6y dy dx, perfect. Is equal to, what's the derivative of 25? 0. How do I get the dy dx all by itself? Subtract 14x. And we'll divide by negative 6y. So dy over dx is equal to, can I simplify 14 over 6 to what? 7 over 3, or 7x over 3y. So if it says find dy dx, this is the same thing as saying find the derivative. It means the same thing. If you have y's scattered in your question, you're going to have to find the derivative using implicit differentiation. Any questions here? What would we do for the next one? Product rule. And then we'll have to do the chain rule too. We practiced one like that. Let's look at the next question. So we're given g of x equals x squared plus 1 times f of x, and f of 2 is 3, and f prime, or f prime of 2 is negative 1, or the derivative of f is at 2 is negative 1. We want to find the derivative of g, and then plug 2 in. So how would we find the derivative of g? What would we need to do? Not yet, because we don't know what g of 2 would be, so we can't just plug in 2 into the x's and we have f of 2. So we can't just plug in the 3 right away. Let's take the derivative first. How would we take the derivative of something like this? Product rule, perfect. We're going to do the product rule. So our product rule is the first times the derivative of the second plus the second times the derivative of the first. So our first would be x squared plus 1 times the derivative of the second, which would just be the derivative of f. We don't know what it is yet. Plus the second, so f of x times the derivative of the first. What's the derivative of x squared plus 1? 2x. So this is g prime of x. This is our derivative of g. Now let's find g prime of 2. So I'm going to plug 2 into all of my x's. So 2 squared plus 1 f prime of 2 plus f of 2 plus 2, or times 2 times 2. So here we would get 2 squared plus 1 is 5. What's f prime of 2? Negative 1. Plus, what's f of 2? 3. And 2 times 2 would be 4. So 5 times negative 1 is negative 5. Plus 3 times 4 is 12. So g prime of 2 would be 7. So same thing we've been doing, tries to make it a little bit trickier for you because it doesn't tell you what f of x is, but do the product rule. Since we're multiplying, do the product rule. If we were dividing, we'd do the quotient rule and then just plug it in. What would we do for the next one? Quotient rule. And let's do the next one. So here we want to find the derivative. We have to use implicit differentiation here. So we're going to take the derivative of everything. Be careful here. We need to take the derivative of y. Y is just all by itself on that side. We're not going to leave it as y equals because we're taking the derivative. So don't forget to take the derivative of this y. What's the derivative of y? dy dx, perfect, is equal to, what would I do next? Product rule. So the first times the derivative of the second plus the second times the derivative of the first. So our first would be x times the derivative of the second. What's the derivative of y squared? 2y dy dx plus the second, which would be y squared, times the derivative of the first. What's the derivative of x? 1. Then plus, next we have x. What's the derivative of x? 1. And then what's the derivative of 4? 0. So be careful here. Make sure when you take the derivative of x, you put the 1 there. Sometimes we forget because it doesn't have a coefficient, but that coefficient is 1. So don't forget that. Let's simplify. dy dx is equal to 2xy dy dx plus y squared plus 1. Not really a lot of simplifying we can do there, but what would we do next? Awesome. I'm going to move the 2xy dy dx to the other side. So dy dx minus 2xy dy dx is equal to y squared plus 1. What would we do next? Awesome. Take the dy dx out. We're going to take out that GCF. dy dx. What are we left with when we take it out? Awesome. 1 minus 2xy. Don't forget the 1 there. If I'm dividing out a dy dx by dy dx, we need the 1 in that spot. So don't forget the 1 there. And then this is equal to y squared plus 1. What's the last step? divide. We're going to divide by 1 minus 2xy. So dy dx is equal to y squared plus 1 over 1 minus 2xy.